There are several examples of partial differential equations. And partial differential equation we abbreviated with PDE. The first example we are going to consider is the one-dimensional wave equation, which takes the following form. We have on the left side the second derivative of u with respect to t, and on the right hand side of the equation we have c squared, where c is a constant, multiplied with the second derivative of u with respect to x. X is the spatial coordinate and t is the time. So the unknown variable u, in this case we call it u, is dependent of the spatial variable x and the time t. Let's consider another partial differential equation. This is the one-dimensional heat equation. It looks like the first one, but instead of taking the second order derivative, we take the first order derivative of u on the left side. So this is the one-dimensional heat equation, and the variable u is, as in the above example, dependent on x and t. Third example is the two-dimensional Laplace equation, typical problem for heat transfer, stationary heat transfer, for example. And in this case, we have a solution which is dependent of only the two spatial coordinates. In two dimensions, it's x and y. And this equation, on the left side of the equation, we have the Laplacian. That is the second derivative of u with respect to x plus the second derivative of u with respect to y. Let's also consider the two-dimensional Poisson equation. It looks like the two-dimensional Laplace equation, but the only difference is that the right-hand side is not necessarily zero. So here we can have a function which is dependent of x and y. A typical example would be when you have some heat source inside the material. The fifth example is the following. It's a two-dimensional wave equation. For the wave equation we take the second order derivative of u with respect to t on the left side, and on the right side we have c squared, where c is, as above, a constant, and multiply it with the Laplacian of the unknown variable u. So as you can see here, in this case the solution u, or the unknown variable, is dependent of both spatial coordinates x and y, and also the time t. The last example we are going to consider in this at this stage is the following: three-dimensional Laplace equation. It looks like the two-dimensional Laplace equation, but we add a third term, namely the second derivative of u with respect to z. So this is typically a three-dimensional heat conduction problem, for example.